Hello friends, Mr. Burrell here. We've just started this unit talking about graphing trigonometric functions. So in the last video I talked about the parent trigonometric functions, what they look like for sine, cosine, and tangent. We kind of discovered those using our graphs and using our calculators and using a couple other tools. So hopefully now we know a little bit what these basic parent trigonometric function graphs look like. Now we're going to start talking about transformations of those graphs, and we're going to start by talking about vertical shifts or changes to the midline of those graphs, and we're going to talk about amplitude. So we're going to talk about how we can graph these different types of functions with these changes, with these transformations. So by the end of this video, this is what I hope you're able to do. Hopefully you're able to determine the vertical shift or the midline from a trig equation and graph the midline from a trig equation. Hopefully you're able to determine the amplitude from a trig equation and graph the amplitude from a trig equation. And then I want you to be able to write the equation of a trig function with vertical shifts or amplitude changes from a graph. So we're going to be going both ways, from equation to graph and from graph to equation. So let's look at this. So just as a reminder, let's remind ourselves, what do these graphs look like? I have these top graphs right here are in degrees, and these bottom graphs right here are in radians. So I'm going to graph first on the degrees one and show you on the radians. On each of these graphs, I'm going to say these marks right here are positive and negative 1, just for the sake of being able to help you visualize these graphs. So a sine function is going to start at 0, and it's going to reach its peak at 90 degrees, and then hit back at the x-axis at 180 degrees, and then it's going to hit its valley right down here at 270, and then start back over at 360 degrees. Remember, the period of a sine function is 360 degrees, or in other words, it takes 360 degrees to go through one full sine wave. So I hit the x-axis at 0, 180, and 360, and then I cap out at 90 degrees and 270 degrees. In radians, it looks the exact same. Man, I'm so good at drawing these. Looks the exact same. Instead of 0, 180, and 360, I cross the x-axis at 0, pi, and 2 pi, and I cap out at pi halves and 3 pi halves. So that is a sine function, or a sine wave. So cosine, let's remind ourselves what cosine looks like. Cosine looks very similar to the sine function. Instead, though, it looks kind of like this. So I'm going to go ahead and draw the graph, and then I'll explain it a little bit better. Man, that's beautiful. Okay, so the cosine wave, again, it has a period of 360 degrees. It starts at the top here, goes down and back up, back to its starting point, and it takes 360 degrees to do that. So on the sine wave, I touch the x-axis at 0, 180, and 360. And then I capped out at 90 and 270. On this graph, on the cosine graph, I touch the x-axis at 90 and 270, and I cap out at 0, 180, and 360. So notice everything's just shifted, like to the left, 90 degrees. Or you can think of to the right 90 degrees. Left or right 90 degrees. So then if I plot this same thing on the radian graph here, it's going to look something like that. Again, capping out and bottoming out at 1 and negative 1, crossing the x-axis at pi halves and 3 pi halves takes 360 degrees or 2 pi radians for a full rotation of this wave. And notice on both of these, the midline is at x equals 0. Okay, for my tangent function, remember I'm going to go ahead and have asymptotes at 90 degrees and 270 degrees because my tangent function is going to look something like this. Right there, that's kind of what it's going to look like. On the radian function, on the radian graph, I'm going to have asymptotes at pi halves and 3 pi halves, and it's going to look the same, kind of like this. So again, with a tangent function, the midline is still at x equals 0 here. And the period of a tangent function is 180 degrees because it only takes 180 degrees to go through one full tangent wave. Okay, so that's just a reminder of my sine, cosine, and tangent functions. So now we're going to talk about the transformations of these functions. So first we're going to talk about a vertical shift, or moving my functions up and down. So vertical shift, or the midline, is the amount a graph is shifted up or down. It moves that midline from 0 either up or down. To find the vertical shift from an equation, we find the constant added or subtracted to the function. So y equals sine of theta plus or minus c. This c value that's being added to the sine or cosine or tangent function is going to move the midline up or down. So let me pull this over here real quick. So I pulled up my sine wave here, and I have it in radians. My graph is in radians, so you'll notice right here I have my sine wave going from 0 to 2 pi, one full rotation, and then it just keeps on going forever and ever in both directions. So right here I have a little slider so I can change the value of c. So notice what happens when I change the value of c. I have sine of x plus c. So right now it's just sine of x plus 0. Notice what happens when I change the value of c. This is sine of x plus 1, sine of x plus 2, plus 3, plus 4, plus 5, etc., 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 minus 1, minus 2, minus 3, minus 4, etc., etc., etc. So look, when I have c equals 3, sine of x plus 3, notice my midline right here is at x equals 3. Let me pop up my cosine graph. Same thing, when I have cosine x plus 3, my midline is at x equals 3. If I have tangent of x plus 3, my midline is at x equals 3. So the graph doesn't really change that much, it's just shifted up or down. The amplitude is still 1, but the midline changes according to what that c value is. Okay, so let's look at some examples. So right here it says, write the vertical shift or midline of the function, graph each function using degrees or radians. So both of these graphs you see here in degrees. So I'm just going to draw real quick. This is where my midline would have been, and this right here is approximately, this right here is approximately what my graph would have looked like, my sine graph. But notice I have sine of theta plus a negative 2, or in other words, negative 2 plus sine of theta. So now my midline is going to be right here. So I'm starting at the y-axis, and I'm going to go up 1 to 90 degrees, down hit the midline at 180 degrees, go down to 270 degrees, down 1 unit, and then back up to 360, etc., etc., etc. So that would be my transformed graph with the midline change, and I go ahead and write my midline is x equals negative 2. So I've just shifted the whole graph down 2 places. For this function, y equals cosine of theta plus 1. That means my midline is going to be at plus 1. So cosine, the amplitude hasn't changed, so my original cosine graph would start 1 unit above the midline. So I'm going to go ahead and start at 2. And notice I'm going to go down to 90 degrees, 180, 270, 360. So it still takes 360 degrees to go through a full rotation, but instead now I'm shifted 1 unit up. So now I cap out at 2 and I bottom out at 0 instead of capping out at 1 and bottoming out at negative 1. Just again to give you a visual, this is approximately what my graph would have looked like before. Just shifted up 1 unit. Then I could keep drawing this if I felt the need. Okay. This is one in radians, so notice it's not going to change what I do all that much. It's just instead of taking 360 degrees for a full rotation, I'm going to take 2 pi radians for one full rotation. So here my midline is now at negative 1. So my cosine wave is going to look something like this. I'm going to go ahead and start 1 unit above the midline. I'm going to go just like that. Then I could keep going if I wanted to, just like so, etc., etc., etc. These graphs don't have to look exactly perfect, but the big thing that I'm looking for right now is that it takes a full 2 pi radians to get a full rotation of my cosine wave, and that the midline is at x equals -1. Here, for y equals sine of theta plus 2, that means my midline is going to be at +2, and my sine wave, still starting right here, is going to look something like that. Again, I'm not perfect at drawing these graphs, but they should look something like that. The big thing, recognizing that it takes 2 pi radians for a full rotation of the wave, and that the midline is at x equals 2. So again, the graph looks the exact same. It's just shifted either up or down. Okay, so that's vertical shift, or the midline of a function. Next, I want to talk about amplitude. So a reminder that the amplitude is the height from the mean. We say the mean, but we can talk about that being the midline. So the height off the midline value of the function to its maximum or its minimum. So when we thought of a sine wave or a cosine wave, from the midline, either the distance to a maximum or the distance to a minimum, that is the amplitude. So far we've just talked about the amplitude being 1. The amplitude has been 1. So to find the amplitude from an equation, find the constant multiplied to the trig function. So this value in front of either sine, cosine, or tangent, we're going to call it a. This value that's out in front of sine being multiplied, that's going to change the amplitude. So let me pull my graph over here again. I have these functions right here, y equals sine, cosine, and tangent, all being multiplied by a. And I'm going to go ahead and change the a value so you can see what happens when I change the a value. See what happens when I drag it up. So this is a equals 4, a equals 5, a equals 6, etc., etc. So notice a equals 6. Now my amplitude is 1, 2, 4, 6. The distance from the midline to the crest, or the distance from the midline down to a valley, down to this minimum, is 6 units. So the bigger that number is, the kind of steeper, the more stretched out that function is. Notice what happens when I go negative. Whoop. Just kind of flips everything upside down and then does the same thing. So my original sine wave starts going up and then goes back down and back up again. When I flip it negative, it goes down, up, and then down again. Let's look at cosine for an amplitude change. Again, the crests and the valleys are going to go up and down. So when I have, say, a equals 5, that means the amplitude is 5. So on this cosine wave, I start at y equals 5 here, go down all the way to -5, all the way up, back up to negative, or +5. Tangent, let's look at tangent for a second. Tangent is kind of unique because tangent doesn't have an amplitude, but we can just think of the number in front of tangent acting as a vertical stretch. So as this number gets bigger, the graph gets more stretched, and as this number gets a smaller decimal, so like 0.8, 0.7, 0.6, 0.5, it's going to be kind of squished, so it's going to be less of an angle right here. And we'll do some examples of the tangent function here in a little bit. But that's what the a value does for each of these graphs. It stretches it out or makes the amplitude bigger. Okay, let's look at some examples. So it says, write the amplitude of the function, graph each function using degrees or radians. So let me move my face out of the way again. So right here I have y equals 4 times cosine of theta. So the amplitude is going to be 4, which means that from the midline to a maximum or a minimum, that distance is going to be 4 units. So my cosine function originally is going to look like this. It's going to start at 1, and I'm going to go ahead and go like this. My cosine function is going to look something like this. But instead of my amplitudes being 1 unit, my amplitudes are going to be 4 units. So anytime I have a maximum, that maximum is going to be at y equals 4. Anytime I have a minimum, that minimum is going to be at y equals -4. So I still am going to cross the x-axis in the same places. I'm just going to be stretching this out so my crests and my valleys are at 4 or negative 4. And then I could keep going like this forever and ever and ever and ever, repeating the cosine function every 360 degrees. This one, so again, that was y equals 4 times cosine of theta. Number 2 here says y equals 1/2 times cosine of theta. So my amplitude is going to be 1/2. So instead of stretching it out, I'm going to kind of squish it down. Because this right here, again, would be my parent cosine function. But now instead of my amplitude being 1, my amplitude is going to be 1/2. So it's going to be really really squished down here. So that would be my transformed cosine function. And I could keep going here just like so. So my amplitude, instead of being at 1, all my valleys and my peaks, my maxes and my mins, are at y equals 1/2 or negative 1/2. Okay, let's do another one. This one is y equals 2 times the sine of theta, and now each of these graphs are in radians. So my amplitude here is going to be 2. So my traditional sine wave would look something like this, repeating itself every 2 pi radians, with my maxes and minimums at y equals 1 and negative 1. Now I need my maxes and my mins to be at y equals 2 and negative 2. So I still cross the x-axis in the same place. My midline is still at x equals 0, but my amplitude is 2 units. So my maxes and mins are 2 units away from the midline. And again, I could keep going forever and ever and ever. Y equals 3 times the cosine of theta means my amplitude is going to be 3. So that means instead of my cosine function looking like this, with my amplitude at 1, so I reach positive 1 and negative 1, my maxes and mins are going to be 3 units away from the midline. Conveniently, my midline here is just the x-axis still, so my maxes and mins are at 3 and negative 3. So I still cross the x-axis in the same place, but reach my maxes and my mins at 3 and negative 3, 3 units above and below the midline. So that's how we find and graph the amplitude of a function. Okay, now I'm going to do a couple examples where we're going to, and you'll see some examples like this on your homework, where I give you a graph. I want you to find the vertical shift or the amplitude, and I want you to write what the equation for that function would be. Okay, so let's look at this. Some of these are going to have both. They're going to have a vertical shift and an amplitude change. So notice here, I'm going to go ahead and draw where the midline would be. So this right here at negative 1 is going to be the midline. So that means C is negative 1, because that's directly down the middle of my graph here. So then I start on the midline. My graph starts on the midline at the y-axis, so I know that this is going to be a sine function. So I start on the midline and go up, down, and then back up again. Okay, so now I need to determine what the amplitude is. Well, my amplitude, how far above or below my midline do my maximums and my minimums reach? Well, 1, 2, 3, 4. 1, 2, 3, 4. So my amplitude is 4. So this is what my function equation would look like. Y equals 4 sine of theta minus 1. Meaning my amplitude is 4, and my midline is shifted down by 1 unit. So again, I looked at the graph, I kind of analyzed it. Where's my midline? What's my amplitude? Which function am I using? Sine, cosine, or tangent? And then I was able to write what the equation was. Okay, now I want to go ahead and do a cosine function. I want to do a cosine function. So let's do number 4 here. So I'm going to go ahead and sketch where I believe the midline would be for this function. So there's my midline. So my midline C is going to be negative 2. I'm shifting down 2 units. And I'm starting up at a maximum on the y-axis, going down and then back up again. So I know that this is going to be a cosine function because it doesn't start on the midline, it starts at a maximum. And then I need to find what my amplitude is. How far above or below the midline do my maxes and minimums reach? Well, it looks like my amplitude is just 1/2. It's very shallow there. So it's a cosine function. My vertical shift, or my midline, is at -2, and my amplitude is 1/2. So my function would be y equals -2 cosine of theta, 1/2 cosine of theta minus 2. So that would be the equation for my cosine function matching with this graph. Okay. So those are the transformations I want to talk about in this lesson. I'm now going to go over some of the problems off of your homework. We're 20 minutes into the video. Now we're going to go over some of the problems from your homework. Specifically, we're going to go over some tangent problems because we didn't do a lot of tangent problems beforehand. So this problem says, write the vertical shift, midline, and the amplitude of each function, and then graph it. So these are both in degrees because the graph along the x-axis I'm given in degrees. So I'm going to determine if there's a vertical shift or an amplitude happening in either of these functions, and I'm going to determine what those are and then graph them. So here I have y equals tangent of theta plus 1. There's nothing being multiplied in front here, so there's no amplitude. There's no change in amplitude, so the amplitude is just going to be 1. And then do I have a vertical shift? Am I moving the midline at all? Yes, I have a constant being added out here, so my vertical shift is going to be 1. So instead of my midline being at 0, my midline is going to be at 1. This is a tangent function, so I have asymptotes at 90 degrees, 270 degrees, 450 degrees, etc., etc., etc. So I start on the y-axis at the midline, and my tangent function goes like this. Start right in between here on the midline. My tangent function is going to look like this. So again, I cross the midline at 180 degrees, and then again at 360 degrees. My tangent function is going to look something like that. My tangent graphs, I don't expect you to make them look super, super perfect, but I should see these asymptotes at 90, 270, 450, etc. So I can see that the period is 180 degrees. And I should see at 180 degrees, 0, 360, etc. that my tangent function crosses the midline. So that's what that graph would be. And my vertical shift, or my amplitude didn't change. I didn't have a change in amplitude, but I did have a midline change up by 1 unit. Now, that was number 5 on your homework. Number 17 on your homework says y equals 4 times tangent of theta. So I have a number being multiplied in the front of tangent, so that's going to mean an amplitude change of 4. And there's no midline change, so I won't worry about changing my midline. My midline is still at the x-axis. I have asymptotes at 90 degrees, 270 degrees, and 450 degrees. I'm still going to cross my midline at 0, 180 degrees, 360 degrees, 540 degrees. But how does my tangent function change again? There's not an amplitude for my tangent function because it just keeps on going forever and ever and ever. So what this is going to do is going to stretch my tangent function out. So it's going to be really, really steep as it crosses the midline. That's what that's going to do, is just make it a little bit steeper. Again, I'm not super critical as to the perfection of drawing those graphs, but I should notice that this is a lot steeper. It's been stretched out a lot more. Okay, here's some more homework problems. Write the vertical shift, midline, and amplitude of each function, and then graph. So these are back to some sine and cosine ones. Number 6 on your homework says y equals -1 plus cosine of theta. So I have a constant that's being added to my sine slash cosine function. So that means I'm going to have a midline change. So my midline is now at -1. My amplitude hasn't changed, so my amplitude is still just 1. So my midline is going to be right here at -1. So this is a cosine function, so I start on the y-axis at my amplitude, at my maximum, which is 1 unit above the midline, and then I'm going to go ahead and draw my cosine function. So I'm going to cross the midline at pi halves, I'm going to have a minimum at pi, cross the midline at 3 pi halves, and then come back up to my maximum at 2 pi, so I make a full rotation over 2 pi radians. So my cosine function is going to look something like this. Making sure that I did a full rotation between 0 and 2 pi radians, because that's a full period, and that my midline is at -1. So again, the same basic exact graph as my traditional cosine function, except it's shifted down 1 unit, because my midline has been shifted down. That was homework number 6. Homework number 14 says y equals 2 sine of theta. This number being multiplied by sine means my amplitude is going to change by 2 units. My midline doesn't change, but my amplitude does. So this right here is my traditional sine function, making a full rotation between 0 and 2 pi. So now my maximums and minimums, instead of being 1 unit above and below the midline, they're going to be 2 units above and below the midline. I'll still cross the x-axis in the exact same places, but my maximums and my minimums will be 2 units above and below the midline instead of 1 unit. And I could keep going if I wanted to. Okay, the last homework problem I want to go over, this is number 23 on your homework. So this is given a graph. We're going to go ahead and write the vertical shift and the amplitude of each function and then write an equation. So we're going to find the amplitude, the vertical shift or the midline, and then we need to determine if we're using sine, cosine, or tangent. Okay, so on this graph right here, here is my midline. Right down smack dab the middle of that function, so my midline is going to be at -2. And then my amplitude, how far above and below this midline are my maxes and mins? Well, it looks like those are 2 units above and below the midline, from -2 up to 0, from -2 down to -4. And then I start on the y-axis at a maximum, so this is going to be a cosine function. If it was a sine function, I would have started right here, so this is going to be a cosine function. So here would be my traditional transformed function, A representing amplitude, C representing the midline. So my function is going to be y equals 2 cosine of theta minus 2, substituting the A and C values that I found for my midline and my amplitude. Midline, amplitude. And if you want to go and type this into your calculator or type this into Desmos, you can double check and make sure that indeed it looks like this. Okay, that's everything I have for you today. Hopefully now you're able to determine and graph midlines given a trig equation, determine and graph amplitudes given a trig equation, and then given a graph of a trig equation, hopefully you can identify what the vertical shift and amplitude changes are and write what the equation would be. So I hope that was helpful. Please reach out to me if you have any questions whatsoever, and I hope you enjoyed that as much as I did.